Today, we're going to dive into VS Code and talk about the complexity of VS Code. When you open a VS Code project, you will find it's a monorepo mixed with TypeScript, C++, and Rust, targeting not only Windows, Mac, and Linux, but also remote servers and web workers. So why is VS Code's source code so complex? Because it's composed of three kinds of complexity introduced by different layers. First of all, a large project needs advanced design patterns to decouple components. VS Code uses many design patterns, such as dependency injection, inversion of control, observer pattern, command pattern, and so on. Second, VS Code is a cross-platform project. The desktop client is based on Electron, and Electron introduces multi-processes and complex IPC. Meanwhile, the build system is much more complex. The last and most important one is VS Code's specific complex architecture. VS Code has multi-layers, such as base, platform, editor, workbench, code, and server. And VS Code has multiple targets, such as common, browser, node, Electron main, and Electron sandbox. And VS Code has multi-protocols, such as language server protocol, debug adapter protocol, remote development protocol, and so on. Today, we will try to break down VS Code from the first aspect, design patterns. So, what are design patterns? They are reusable solutions to common software design problems. The region of design patterns is this book, Design Patterns, Elements of Reusable Object-Oriented Software. It was written by the Gang of Four, and one of them is Eric Gamma. Eric Gamma helped shape VS Code with his IDE experience. He is also the author of another famous IDE, Eclipse. The purpose of design patterns is to provide proven architectural solutions that improve code maintainability and scalability. As VS Code is such a huge project, there are many design patterns in VS Code, such as dependency injection and inversion of control, observer patterns, command pattern, extension pattern, and so on. Today, we will mainly focus on DI, dependency injection, and IOC, inversion of control. By using DI and IOC, dependencies are provided externally rather than created internally. Control flow is inverted. Framework controls object creation and lifecycle. They are widely used in Spring, Angular, and Next.js, and there are many benefits from DI and IOC. Modularity. Each service has clear responsibilities. Testability. Easy to mock dependencies for unit testing. Extensibility. New services can be added without modifying existing code. Performance. Lazy loading of services when needed. Now, in order to figure out how DI and IOC work inside VS Code, let's try to add a dummy service to VS Code. Step 1. We create an interface, iDummyService, that has a run method. Step 2. We use createDecorator to generate a service identifier for our service. Step 3. We implement our interface in DummyService. Step 4. We need to register it as a singleton. You can see that we do not need to manually create and destroy our service. The DI and IOC system will take care of the life cycle of our service. So, how can we access our service? It's quite simple. Let's use an action to call the run method of our service. VS Code will pass the service accessor service as the accessor parameter. We can easily get our service by calling accessor.get. The parameter is the service identifier created by createDecorator earlier. Then we can call the run method directly. Now, we have figured out one of the complexities of VS Code. Subscribe to my channel. We will dive into Electron in the next video. Till next time, bye.